Alright, Andre, here's my Sprint 2. First, I'll show you the visitor pattern working with Sphere to AABB collision test, which is working just fine. Um, and then for my AABB to AABB collisions, they are also still working, or excuse me, they are working, and this is using the visitor pattern that you gave us. And so basically you have, I'll show you. So we have our collision volumes, would have our collision volume, which is checking against collision volume. So we have collides with for each volume. So AABB has collides with for sphere and AABB, and sphere has the same thing. Excuse me. And yeah, it's pretty simple. You know, it's basically ripped right off of your lecture. We got the accept visitor, which returns the collision volume colliding with this, and it either is colliding with a sphere or colliding with the AABB for both of them. Yeah, and I have, I'll show you so for the update collision volume for the AABBs, I have a find max for, or excuse me, a find max, find min functions, and then a within interval function to, you were talking about having those tools set up, and that way I can reuse these over and over. Right now I have them in collision tools because I don't really know where else I would ever find, well, I might move find max and min outside of collision tools because that's something I can use at any point in time to find a max or a min. But within interval I'll leave in collision tools, and essentially, well, max and min are easy. Within interval, I basically check the first max against the second min, and the first min against the second max. The first max, if it's less than the second min, or the first min is greater than the second max, then that would make the box not in the same, excuse me, the axes for those boxes wouldn't be in the same place, and that's why it returns true. So we want it to return false for collision, and that's how it's set up in here. So if it returns true, I get a false, which means it doesn't collide. And if all of these fail, then I have a collision. Alright, 1 second. Alright, just to be clear about the whole strategy pattern for my collision volume, just showing you the code real quick. It's basically for setting my collision volume. It's really simple, easy forward method, but this is where my strategy pattern is, which is shown in my class diagram, which I have now lost. So again, right, so that's why I had this P collision volume, this pointer inside my collision object, which gets set to whichever collision volume I call, or excuse me, whichever collision volume the user desires based on the set collision volume method. Okay, and so for my research, I did a little looking through that physics book that I showed you last week. It actually has a lot more detail for a physics engine in development in its entirety. I thought it had much lower level stuff for, the basic kinematics, but it seems like it's going to be really detailed. So I don't know exactly how I'll be able to use this other than like for a particle system, because it has a really nice detailed section on creating a particle system. I know that's something you're going to be talking about later, so I'll see how I can use the basic particle system, which has, excuse me, not the particle system, that's in addition to the particle system chapter. There's a general forces section which talks about like having basic gravity throughout an entire engine. And I think that would be the closest thing I can get to the kinematics portion of what I wanted to, like a very small section for physics, having like the basic kinematics of gravity and small forces for gravity, or small forces applied to an object based on the gravity to simulate physics in the world. For the collision volume, excuse me, for the collision stuff that I wanted to research, I looked further into my book, and there is a whole lot of stuff for the bounding volume hierarchy method that you were talking about. and it goes through a bunch of like different methods in doing that, whether you're doing the top down or bottom up construction for the trees. And then it basically talks about having different traversal methods through a hierarchy. And then it also talks about optimization of these, I guess, of the collision system in general to, essentially make up for anything that, like, if I wanted a more precise collision system at that, which would be costly, there's a way for me to optimize or find the best optimization for a collision system, I guess would be the correct way to say that. But yeah, I mean, it's a lot of good reading. So far I've learned a lot. Hopefully, when we talk about the OVBs tomorrow, which I've already read up on OVBs, so that should be pretty easy for tomorrow's lecture. I'll be able to implement that. And the following week, when you give us the lecture without code, I'll be able to use that lecture to end my book to help me out and figure out how to code that in. I'm looking forward to actually testing that out, because this collision stuff, like the AVBs that we did this week, was pretty fun. So hopefully it keeps being fun, and maybe I might skip physics altogether and go straight with this awesome collision system. And long video. Alright, see you tomorrow, Andre.